one of the important concepts is that of the concept of coefficient of restitution or coefficient of resilience. Now what is that? Let's say the two bodies, they are coming from here and they are colliding. When they are colliding, there are two kinds of impulses which are generated. One is during when the deformation is taking place, and then because of elasticity, when the collision has taken place, now these two bodies, they try to regain their original shape, size and volume. That is what we call elasticity. So one is deforming impulse and the second is recovering impulse. When we say coefficient of restitution or coefficient of resilience, it is denoted by E. This is denoted by small e, and this is P dt, integral of P dt upon F dt. This is what? This is recovering impulses. Obviously, when this is deformation is taking place or recovery is taking place, the force at any instant is different from the other instant. So that's why there is integration. So from here we see that is E is ratio of recovering impulses over deforming impulses. Generally, the recovering impulses, they are weaker as compared to the deforming impulses. So that's why E is generally less than 1. E is equal to 1 only for the perfectly elastic collision. So let's see what is E. This is E is equal to 1 for, we say, perfectly elastic collision, or E is less than 1 for inelastic collision. And here we have also one case where E is equal to 0. This is called perfectly inelastic collision, and this is also called as perfectly plastic collision. We have done this case earlier also, where in perfectly inelastic collision or perfectly plastic collision, the two bodies, they collide, combine together and move as a single body with a common velocity. So that is perfectly plastic collision, and over there E is equal to 0. When the derivation of this is done, which is not under the preview of our course, this comes out to be, E comes out to be minus velocity of separation over velocity of approach. So this comes out to be minus velocity of separation by velocity of approach. Why minus comes is, it is through the derivation only it comes, that is E is equal to minus velocity of separation by velocity of approach. And over here, one thing to understand is, when you talk the velocity of separation or velocity of approach, remember this is very, very important that this is along the common normal. This is velocity of separation or velocity of approach, they are along the common normal. What does that mean? It means, suppose here is a wall, this is a wall, and this body is, let's say it is moving in this direction. It is moving with 10 meters per second parallel to this wall. So obviously, at what rate it is approaching the wall? It is not approaching, all the time it is maintaining the same distance. So its velocity of approach is equal to 0. Now what happens? Suppose it has a velocity in this direction. Over here, now it is 10 meters per second at an angle of 30 degrees. Now it is moving in this towards the wall like this. So now velocity of approach is not 10 meters per second. This velocity can be broken into two parts. One is 10 cos 30 degree meter per second. The other is 10 sin 30 degree meter per second. So because of this velocity, now this velocity is gone. We have broken this velocity, resultant velocity into its components. This is approaching the wall only because of this velocity, not because of this velocity. This is parallel to the wall. It is because this velocity, this is moving in this direction. But it is moving towards the wall only because of this velocity. So over here, the velocity of approach is not 10 meters per second, but 10 cos 30 meters per second. And this is along the common normal, like obviously when it goes over here, then this is the normal over here. This is the normal and this is a tangent. So what we say is that is this is along the common normal. Suppose a body coming like this and the other body is coming like this. Let's say they collide over here. They collide over here. Then which are the velocities which will be taken into consideration? See, this is going to be common tangent and this is going to be common normal. So all the velocities, they will be taken in this direction along the common normal. that means that is the component of this velocity which is in this direction, that will be taken into consideration. And for this body, this velocity, if this is a velocity, then this velocity that is along this way, this will be taken into consideration, not the components which are tangent. It is all the velocities, they are considered along the common normal. Now E is equal to minus velocity of separation over velocity of approach. And this comes out to be, suppose there are two bodies we are colliding, so it is minus V2 minus V1 over U2 minus U1, right? This is an important formula that you should remember. 1 and 2, that is for the objects. V2 is the velocity of object number 2 after the collision has taken place. V1 is the velocity of the object number 1 after the collision. U1 and U2, they are the initial velocity. Initial velocity means velocities before the collision for object number 1 and 2 respectively. If we look, that is what is going to be the diagram for this. This diagram also you should remember. Let's say this is, there are two bodies, and this scenario is on this side of this separation, we are saying that is before collision. This is very important. And this is, scenario is after collision. And let's say this is the common normal. What is this? This is the common normal. This is the common normal I have drawn. So all the velocity will be taken only along this common normal. Let's say this is object number 1, this is object number 2, this is object number 1, this is object number 2. So this is velocity, suppose it is U1 at angle alpha, any angle alpha, arbitrary angle alpha. This is U2 at any angle beta. This is V1, gamma we can take it as, and we can take it as this as delta. V1 and V2, these are any arbitrary velocity. This may be this direction, any direction. So if we use this one, that is velocities, they are along the common normal. So it means, and these are the real velocities. They may be along the x-axis, y-axis, in any direction they may be, but we are interested in velocities along the common normal. So in scenario like this, if we intend to use this formula, so E comes out to be minus V2. V2 is V2 cos delta, because we have to find the velocity along the common normal. This is a common normal, this is a common normal. So the component in this direction that we take into consideration. V2 cos delta, V2 minus V1. That is V1 cos gamma upon U2 cos beta minus U1 cos alpha. Very, very important, this diagram, this and this. This writing on the board is very important if you wish to understand and apply coefficient of restitution, or what you call as coefficient of resilience. This is very important. Number 1, E is equal to minus velocity of separation by velocity of approach. Velocity of separation obviously V2 minus V1. Approach U2 minus U1. This is nothing but the relative motion, and this is along the common normal. That is along the common normal. This is a diagram, and then we have used this. All the components we have taken along the common normal, and this comes out to be like this. Let's apply this through some examples.